In this lecture, we're going to trigger the attack parameter with our code. Players should attack when the attack binding is triggered. For our game, we're using the spacebar key as the input binding. Therefore, if this key is pressed, we should attack. To get started, we should create a constant for the trigger. By defining a constant, we can reduce the likelihood of typos in our program. Open the constants file. Define a new constant in the class called attackAnimatorParam. Set the value to attack. The name should match the parameter name from the controller. In a moment, we're going to need this parameter. Next, open the combat component. We created this component a long time ago. It's responsible for handling the combat of our players and enemies. At the top of the file, let's import the namespaces we'll need for triggering an attack. First, we'll need the UnityEngine.InputSystem namespace. Next, import the RPG.Utility namespace. Our next step is to grab the animator component. This component has the attack parameter. At the top of the class, define a variable for storing the component. Let's call it animator component. The type will be animator. Next, define the awake method. Inside this method, we're going to grab the component by setting the animator component to the getComponentInChildrenAnimator method. The component is at our disposal. The next step is to create an event handler for the attack input binding. Below the awake method, define a public method called handleAttack. The name of our action was called attack. The name should reflect the action's name. You can check the input actions for a refresher on the name. Inside the method's parameters, add a parameter called context with the inputAction.callbackContext type. We should only perform the attack if the player is performing the action. As we learned, the method gets called 3 times when the action is started, performed, or cancelled. Unless we want to trigger the attack 3 times, we should wait for the performed event. In a conditional statement, check the context.performed variable for a false value. If this variable is false, let's return the method. Otherwise, let's start the attack with a method called startAttack. Keep in mind, not all characters are players. Enemies should be able to attack. However, enemies can't run this method as the player can. I think it would be a good idea to outsource the attack logic into a separate method for reusability. Below this method, define the startAttack method. Inside this method, we should start updating the animator controller's parameters. First, we'll call the animatorComponent.setFloat method to set the constants.speedAnimator parameter to 0. Before attacking, we should make sure the character isn't running anymore. They should be perfectly still. By updating the speed parameter, the character will be in an idle state. Next, let's call the animatorComponent.setTrigger method. The setTrigger parameter causes a parameter to be set to true. The name of the parameter must be passed in. Let's pass in the constants.attackAnimatorParameter variable. We don't need to provide a value. Unity handles setting the variable to true. After it has been set to true, the value is automatically reset to false. That should do it. Let's switch over to Unity. Before playing the game, we must register the handleAttack method from the combat component of the attack event. In the hierarchy, select the Game Manager game object. Next, search for the attack event from the player input component. Add a new method and search for the player game object from the scene. As a friendly reminder, search for this object from the Scene tab, not the Assets tab. Lastly, register the combat.handleAttack method. Great! We're ready to test the game. I'm going to dock the game window back with the Scene window. It isn't necessary to keep them side by side anymore. After docking the windows, let's play the game. I'm going to press the spacebar key. As I do so, the attack animation plays. We can trigger the animation as many times as we'd like. That's great! In the next lecture, let's fix a minor problem with this animation.